The relative humidity represents the amount of water vapor the air holds as a percentage of the maximum amount it can hold at a given temperature. 100% humidity corresponds to when the partial pressure equals vapor pressure, at which point adding more vapor results in condensation. Is it possible to have 100% humidity correspond to a lower partial pressure of water vapor than 50% humidity at some other temperature? The answer is yes. You could have 100% humidity at a low temperature. At low temperature, the vapor pressure of water is lower, which means that the amount of partial pressure needed to correspond to that 100% humidity is a lot lower potentially than what would be needed at a much higher temperature. And it is definitely possible to, at a higher temperature, have a more than doubling of the amount of partial pressure of water vapor that can be there before it equals the vapor pressure and condensation starts. So this is definitely therefore possible. Let's check out what the slide says. It agrees. It says, yes, at a higher temperature, the vapor pressure can be considerably higher, allowing for a much higher partial pressure of vapor. So one of the reasons I'm looking at this question is I often have heard people talk about the humidity. And if you're talking about humidity when the temperature is really, really high, sometimes you might say, oh, well, the humidity is only this much. Maybe it's only 30%, but the temperature is really, really high versus, like, let's say it's 30%, right? But it's a hot day versus, like, oh, maybe it's like 70% on a really cold day. But it turns out on a really cold day, that 70% humidity could potentially involve a lot less water vapor in the air and therefore a lot low, maybe less feeling of humidity in the air compared to the hot day. In other words, on cold days it never really tends to feel all that humid, and so the humidity factor that we're told maybe doesn't quite tell the whole story.